Okay, so we've got a bit to go through today. We're going to finish up strings. I'm just going to finish up a couple things with this, and then we're going to go into the more strings section. So we're going to do a lot with strings today, and we're going to talk about some of the other data types that we haven't covered in depth yet in this class. I'll just keep that around. Okay, cool. So yesterday I wrapped things up a little early because I wanted to give these the time that they deserve. So I kind of feel the need to reconstruct the context a bit here. Okay, so I'm certain everybody remembers, but just for the sake of the flow of this, we left off talking about just going over string features. We talked about how strings are immutable. We went over some operators that we can use with strings. We talked about casting to and from strings, which we're going to talk a little bit more about with lists. Some features that strings share in common with lists, indexing and slicing. If you're familiar with the way that works with lists, you can play around with that with strings. The rules are the same. We can enumerate, zip a string in a for loop, and we'll get an enumeration or a zip over the characters of the string. Excuse me, hiccups. We can use len to give us the length of the string. That's going to tell us how many characters, including spaces and new line characters and tabs. So there are several invisible characters that don't have like a visual character, but are still counted as characters. So we can use len. We can count characters in a string. The count method works for strings and lists alike. We can also check for membership. So if you recall, a check for membership is something like A in hello, right? And then that'll be false. This expression will give us false because A is not a member of hello. We could say hey in hello, and even though H and E are in hello here, the substring hey is never in hello, so this will also be false. So things like that. We can check for membership in the string as well. And it can be a single character or it can be a substring. Case transforms, you can make the whole string lowercase, uppercase. You can switch the uppers to lower and lowers to upper with swap case. I should put a dot in front of these. And you can capitalize the first character in the string with capitalize, and that won't capitalize anything else. Some examples of that. We talked about F strings, which allow us to format in other variables. We could format in numbers or booleans or other strings or lists or whatever into the string, and it'll be represented in the string. So a format string is sort of dynamically generated, but it is treated as any other regular string. It's just sort of generated from that template. Cool, so that's what we covered. That was the very last thing we covered today. And then I wanted to talk more about converting to lists because there's enough going on here that it deserves a little time. Okay. So we can take a string and let's just say my string equals, we'll just do a silly string here. Hello world. Give it a little variation, HELO. Okay. And yeah, let's just print my string. We'll just see it in its original form. And then let's call this list of chars. I have to put underscores in. Will be list of my string. Okay. Okay, so if you use the list function to cast a string as a list, you're going to get a list of the characters, and you'll get a list where every element in the list is a single character from the string, right? So I'm printing on line 7 here to show you that, you know, if I convert the string to a list like this, it doesn't change the string. I'm just sort of reinforcing that strings are immutable. And then we're printing out the list, so we can see that there. Oh, sorry, we got a quick question. Where can I find the recorded classes? Okay, we've got links. Good. Thanks for getting that. Okay, so strings are immutable, which we went over. And this, you know, this list function does not actually, wouldn't cause a mutation anyways, but I just wanted to show that, just if anybody was wondering. So that's what happens when you use the list function. Sometimes though, you can think about splitting a string based on a certain character, right? So you might want, often you want, say you want to iterate through the words of a collection. So you need to convert a list or a string to a list of words and then iterate over every word. That's really common. It's really common to want every word from a string as its own individual element. Well, we could think of logic to do that, like string to list of words. We could probably make a function that would do that. But there's a function built, or a method built into strings that helps us with this a lot. So it's called split. So if I have my string here, which I have my string dot split, if I don't pass anything to split, I'm going to get a list of words. So split will allow me to split on any character that I choose, right? So if I don't specify a specific character to split on, it's going to split on all white space characters. And let's just demonstrate this, that it does not alter my string because strings are immutable. Cool, but it just gives me that list of words back. So if I say my list equals my string dot split, we can print my list here. Cool, and that'll give me the same thing. Now let's say I wanted to split on, there's a few L's in here. So let's say I want to split on L. So I'll pass the character L into strings, and let's see what this does. Right, so H, E, and then it splits on these two L's right in a row, which actually gives me an empty string. And then it'll give me O, comma, space, WOR, and then there's another L in the string, and then it splits on that and gives me D, right? So it gives me 1, 2, 3, 4 elements here when I split on L's, right? So I can choose any character or even substring, right? Like I could split on, are there any, what if I said hello world, and I could split on RL, you know, so I could split on any substring as well. It doesn't have to be just a string, just a single character. And I'll get this list. So split is a different way of thinking about how do you convert a string to a list. It gives you control over what the elements in the list are separated by from the string. Notice though, it removes whatever character or substring I specify to split on is not represented anywhere in the list, right? So there are no RL substrings in here, right? If I split on L, there are no L's in the string that was split. We'll let this run. Yeah, so the question is HELLLLLO would print HE and then O, yes. So I split on all those L's, it's just gonna remove all those. Actually, I will get some empty strings, which is kind of annoying in this case, but yeah, same deal. So those L's are not represented, right? Same deal if I split on the whole, if I split on spaces. Here, let me actually pull in, I have an example. Let me pull this in from a different file here. So this is just a short Robert Frost poem that, I don't know, I don't have any special attachment to this. I just like copied it into my text editor to play around with like text processing stuff. And it's just like what I use. So this is called text. So if I split, I'll just change my string to text. Actually, I'll get rid of this one. So if I split on spaces, oops, I'm going to get a whole list of words. Spelled it wrong. So it eliminates, yes, it eliminates the substring that's being passed as an argument, which is to be split on. Why is it different than remove? So remove, there is no method remove for lists, or excuse me, let me rephrase that. Remove is a method for lists, not for strings, and it removes an element from the list. Split does not change the string. Split doesn't change the string, right? Like if I print text, well, now text is huge. Let me pare this down. Actually, let me make this smaller. We'll just do this first little bit here. Oops. Print text. Here we go. Okay, so here's the text after I ran split, right? So the text is unchanged. So remove alters something about a list. Split does not alter the string it's called on because strings are immutable. So that's one difference. The other difference is split's job is not about removing the element. It's about giving you, it's about converting. Think about split as a tool for converting a string into a list of substrings. And you have to tell split, you know, what character should act as a delimiter between each element in the list that split produces, right? So split is called on a string and it gives back a list, right? A list of substrings. So the question is, what character should separate the elements in the list that it produces? So we give it a character. If we don't give it any character, it's going to assume that we want to split on white space. So there are 3 white space characters. There are spaces, new lines, and tabs. This doesn't have any tab characters in it. It just has spaces and new lines. So if we split on this, and we just split on, we don't pass it anything, it's going to split on the white space. And the white space is not represented in the final list produced, right? So it does have the effect of removing things, and there are times where you can use it to remove various elements. There's like ways of doing that, but its job isn't really about removing elements. It's about converting a string to a list in that direction, string to list, right? So when you call split, you call it on a string, you tell it, you give it a character to act as the delimiter, and then it produces a list of strings separated by the character you used as a delimiter. The delimiter is just a fancy word for a separator, right? So in this case, we're telling it to assume to use white space as a separator, which is what we do when we read words. That's exactly what we do when we read English. We use white space as a visual separator to know when one word ends and one word begins. Because if I'm splitting this text into essentially a list of words, because if I do this, then I don't know, it's not easy to tell where the words begin and end, right? So that's just garbage, but that's readable. So we're telling split to split on white space when we do this. Okay. But it takes out the letter you specify. Yeah. So so it doesn't, the letter that you specify or the character that you specify, it doesn't, when you say it takes it out, I think, to me that sounds like to take out means to like remove from, i.e. to change the value. And it's important to note here that it doesn't change the value of the string. So, I'm assuming that that's established, but I just wanted to be explicit about that. So when it takes it out, because think about it, like what would you do with it if you didn't take it out? Like if it didn't take out white space, where would it go? Would it go in like its own element in between these? That might be the most rational solution. Or would it go in the left hand or the right hand portion? I think the easier solution is to just use that character as a delimiter and not make it a member of the list that it produces, right? So it just doesn't make it to the output. And again, its job is like remove is for is to remove elements from a list. It's a method on lists, whereas split is a method on strings that produces a list. Okay, is there a situation where you would use a letter as the delimiter, even if using a letter seems to remove the item from the list? Use a letter as a delimiter. Yeah, I've done that at various times. I can't think of an exact situation like a rubric, like where you should always pick a letter under this situation or anything. But yeah, I've done that before. Oh yeah, we can edit that out. No worries. Okay. Sorry if I'm leaving anybody behind. At me if you still have a question. Okay. Cool. So this is, I appreciate the questions. It's good to explore this stuff because split can be a little funky. Like it can, yeah, there's a little bit going on, right? Like, so that's fine. Let's look at the opposite of split with it, which is join. So join is also a string method, but what it does is join's job is to convert a list to a string. So let's look at join. Trying to think. Well, I guess we'll just rejoin this list, right? So let's say I want to no, I don't want to make this too complicated. We'll just rejoin my list into a my string variable again. So we'll say my string equals, I'm just going to call a string literal like this. I'm going to put the element that I want as the separator, the delimiter, in my string that it's going to produce. I'm going to put it in the empty string here, and or in this string here, not empty string. And then we'll dot join my list. Okay, so let's print out my string. And I'll walk through this code in a second here. Okay, cool. So we have this variable text, which is a short snippet of text. We have a variable myList, which is the result of splitting text on white space. Then we print, text just to see what it is, just to make sure, just to prove that, you know, calling split didn't actually alter text, right? So we call split and we print text. That proves it didn't change text into a list. It just gave us a list of the words, but text stayed the same, still a string. And then we print the myList variable, which is the result of this text.split. We could print text.split directly. That would work fine, give us the same result. And then I'm going to have my string equals space.join my list. So join takes a list to be joined into a string. You call it on the string that you want to act as the separator between all the elements. And then it returns a string with all the elements from the list passed separated by the string it was called on. So that's a little weird. So let's play around with that. So let's just run it. So you can see we have our initial text, we have our list here, and then we have our text again down here. It doesn't look the same because we lost the new lines, but it's the same words. They're just separated by spaces. Let me pare down some of these prints here so we can actually see. Okay. So whatever I want to be the separator in the string that join produces, if I put all these dashes here, that's going to be the separator between the words now. Right, so whose, and then a bunch of dashes, woods, bunch of dashes, these, bunch of dashes, etc. There we go. So most often you'll probably just end up joining on a string with a single space in it, and that'll put a single space between your elements. Cool. So that's split and join. Often, not always, but often when you use split, it's sort of an indicator that you'll use join later. It's really common to split at one point and then join later on down the road. and it's a little funky. So in both cases, split and join are both string methods. That means you call them on a string, so you do string dot split or join. The argument for split is a substring to be split on. And then the return value is a list of elements split by the delimiter that you passed. And then the argument for join is a list to be joined. It has to be a list of strings, though. So a list to be joined, and it returns a string separated by the substring that you called it on. In this case, just a string with a single space in it. So it's a little funky. They'll probably take some getting used to if you're not used to this kind of logic. That's fine. But they're important to know. They are both really powerful and really useful, and they'll be important to know. So join only works on strings. Yes, in the sense that the object that you call it on has to be a string. So it's kind of funny. This is kind of a weird thing with object-oriented programming. If you're new to the idea of object-oriented programming, I find this annoying personally. I find this to be an annoying thing, where you think about an object, you think about a string, right? A string in Python is an object. What an object, what that means is so it has a state, right? Hello world. This is a state. This is one aspect, one stateful aspect of this string, but it also has functions built into it. When an object has functions built into it, we call those functions methods generally. There are certain exceptions to that, arguably, but for now, you can just think about it like if a function is built in as part of an object, it's called a method. You might ask, well, why not just build functions? And I would say that's a good question. Why not just build functions? But the reason why not is because this is the way things are. Some functions are functions, some functions are methods. So when you build in a method into a type, that method only pertains to that specific type, unless you also build in like count, right? Count is built into lists as well as tuples as well as strings. So technically there's three different methods, even though it's the same word, it has the same functionality, takes the same arguments, returns the same value in all cases, behaves the same. Technically, there's three independent methods: string.count, list.count, and tuple.count, declared in three different places, likely. So there's something that I want to show here, and I've been meaning to show this. If you ever want to know what methods are available for a given type, you can print the directory and then pass, you use this function dir, dir, and then you just pass an object of that type. So if I want to know what methods are available to strings, I can print the dir of a string, and you're going to get a lot of output, especially for strings. You're going to get all these dunder methods. If you don't know what these are, then ignore them. If you know what they are, then you probably don't need to hear any of this. But if you don't know what the dunder methods are, just for now, just ignore them. You can come back to those later. The important ones, the ones that you're really going to use, are just the regular named ones without underscores at the beginning or end, the dunders, right? So some of these are going to be pretty obvious what they do by their name, and some of them won't, right? Like capitalize, well, you can probably figure out what that's going to do. Zfill, not so much, right? So if you want to know more about a specific method, you can do help, and you don't have to print out help, and then you'll say whatever the type is, dot, whatever the method name is, Now, a method call requires parentheses. When you're calling help, when you're using help, you leave the parentheses off. It's kind of a weird one. You leave the parentheses off there. We'll run that. And then this will tell me all about zfill, right? So zfill takes in a width and a reference to self. Slash just means a reference to self. Method of built-ins type string instance tells us it's a method of a string, which we already know. Pad a numeric string with zeros on the left to fill in a field of a given width, right? So if you want your string to be of a specific width, I guess you know, and fill it in with zeros on the left-hand side, you can use zfill to do that. The string itself will never be truncated, which means like chopped up or altered, I guess. So that's how you can learn more about different methods available. Sorry, I kind of got off track there. The question was, join only works on strings. Yeah, so you'll only ever do string and then dot join. I guess the simple answer was yes. Wow. Okay. Okay. We didn't talk about replace. Replace. Last one for strings here, and we'll move on. Well, we'll move on to the next one with the next set of slides, which is more strings. So, okay. Replace. So replace sounds like it's gonna change. It sounds like remove, or it sounds like it's gonna change the string that we call it on. But strings are immutable, so it's important to remember replace isn't gonna alter the string we call it on. It's gonna give us a value back. So let's say I'm gonna do dot lower here, which will give me an all lowercase version of this string. And let's say I want to print text dot replace. Now replace takes two arguments. The first argument is the item to replace, which is a string. I want to replace all the i's with u's. How about that? Whose woods these are, you think you know. Whose house, whose the village though. So you can make your text seem ridiculous with replace. And let's just verify that. Let's just look at text and see whether we altered it or not. Right, so our text is still in its original form. Whose woods these are, I think I know. His house is in the village though. So replace, just to be clear here, right? Replace does not alter the string we called it on because it can't. None of the string methods can because strings are immutable. That's what it means for an object to be immutable. None of the methods will change its value. So replace doesn't change text's value. It just gives us a version of text where all the characters that were i's are now u's, right? And I could even replace it with a whole different substring. You know, use house, use, yeah. I think you get the picture. Yeah. Cool. So replace is useful. It's important to remember, of course, it doesn't alter the text. a lot of times, a lot of times you will want to alter the text. I find myself doing something like text equals text dot replace, with something else, A with B or whatever. So occasionally you'll do that, and then that changes the pointer to point at the new replaced version of the string. Cool. Okay, that's everything there. I want to see if there are any breakouts we missed pertaining to split. I'm just going to say no. Let's move on to the next one. Okay, this is a little bit of a review. I think this is worth doing. Strings are simply collections of characters. Strings are declared with either single tick or double tick quotes. I prefer to use double tick quotes because that's what I'm used to. PEP 8, I believe, specifies the use of single tick quotes as the most Pythonic thing to do. So if you want to stay close to the rails with convention, you can use single tick quotes. If you want to use double tick quotes, you can do that. If you're writing on your own code, So this is my own code, so I'm going to write it the way I like to. Cool. So single or double quotes, mostly interchangeable. Single or double tick quotes only work with strings that span a single line. If you want a string to span multiple lines, you use triple single tick quotes or triple double tick quotes. I've mentioned this before, but I think it's worth mentioning again. We talked about this with when we talked about comments. We talked about this as a multi-line comment. This is formally a multi-line comment, and it is formally a multi-line string. The single line comment is not a string. The multi-line comment is a string. So it's kind of a weird one, but yeah, if you ever want to spread a string across multiple lines, you can use triple quotes, and you can do double ticks or triple ticks, either way. Yeah. Sorry, my scrolling sensitivity is not really predictable. I don't mean to fly that around. Hope that's not annoying. Cool. I'm going to post this breakout. It looks like we have a question here. Can join be directed to put together specific parts of the original string instead of the whole original string? Kind of. I mean, you can sort of join parts selectively, separated by one set of things. Like, let's say you want to join words into sentences and then sentences into paragraphs or something. You'd do one join in a for loop where you're accumulating the words into a sentence, and then you join the other one in another for loop that contains the inner one where you're joining sentences into paragraphs. So it's a little bit kind of a yes. It's a good question, though. I think we'll have a problem that will look similar to that pretty shortly here, though. Oh, and I'm sorry, I did not provide this starting text here. Okay, so there's some variables that you can use. Oof, this should not have a capital letter in it. I'm gonna go. I'm gonna extend the time just a little bit. We'll go for a little bit longer. All right, we can wrap it up there. Go ahead and get in your answers. Whatever you've got is fine. I'm going to go through a solution. Oops. There you go. So this is a challenging one. I more so want to see like people just taking on the challenge rather than, you know, everybody getting a correct solution for this. So hopefully you gave this a go. I'm gonna show what I did. Okay, so let's start with the problem statement. Create a function that takes in a string. This function should split the string into a list of lowercase words and make up that string. Return a list of cleaned words. Oops, I returned a string. I just talked about join, so I was like, oh, I must be joining. Okay, there we go. So no more list. There we go. Okay. Return a list of unique, quote unquote, cleaned words. So cleaned, to me, I take to mean without, you know, all lowercase, standardized, remove the punctuation, unique meaning no duplicates. Challenge is to strip away any punctuation. For now, strip away commas and periods. We have this punct list that I'm using here. And to remove common English words. So I kind of diverged a little bit. If you look at this definition, right, this definition line might look incomplete, but this is actually my function head, this whole thing right here. And I figured I would just showcase this for when we talked about functions, we talked about default arguments. So I have a couple default arguments. This is several classes ago, but somebody, you know, many days ago at this point, somebody had asked if I had a good example of default arguments. And as I was going through this, I thought, you know, this is kind of a good example of a good time to use default arguments. The standard by which to solve this problem is kind of flexible, so I just chose to do it this way. So you can see instead of, these are not variables, these are parameters actually. And I'm not baking these values into stone here, but what I'm doing is I'm passing these as parameters because, you know, maybe I would want to use this function in a place where I had different or specific other punctuation or special characters that I would want to remove. And I could pass, let's say, I mean, for example, let's say I only wanted to remove periods, right? I could say, equals period, right? So I could overwrite this default with my own punct list to be used here. And the same thing with the words, common words thing, right? Maybe there were certain other specific words that I wanted to remove. Probably common words isn't the best example. Maybe remove words. I don't know. Words to remove. But this is a good starting place, right? We can have a default. I just wanted to assume this for now. I might make the argument that perhaps in most cases, these are the words that I would want to remove. They're common words or whatever. But if I wanted to supply my own special list, I could supply a keyword argument like this, right? So here's an interesting thing. Some of you may notice I have this star operator up here. The star args prevents me from passing in values for these without supplying the name of the parameter, right? So I can't actually supply a value for punct list by just saying, by just putting a list here, right? It's not going to recognize this as punct list. I have to specifically provide a keyword argument just like this. I have to say punct list equals this. So what the star does is say, you know, everything after the star has to be named on the invocation, and it has to be defaulted in the definition. So it's a little bit of trickery here. If that doesn't totally make sense, then, you know, you can chalk this up to just me kind of going off the rails with this. You know, there are simpler solutions that are fine. But this is something that I wanted to show for people who had questions about default arguments. And this is certainly not your everyday function head, but that's an example. Okay, then for the actual logic, I changed the variable names, right? Punct list and remove words. So I'm doing for punct, which is the punctuation character in the punctuation list, if that character is in the text in, the input text. That's the name of the parameter that I'm taking in for the string. And I don't even need this line. I just put it there. So if it's in there, then I will say text in. The new value of text in, I'm just going to overwrite it, essentially sort of mimicking the behavior of a mutation here. I'm going to say text in equals text in dot replace that punctuation character with an empty string. So I can use replace like this. I can sort of use this, and it kind of acts like, it kind of gives me some of the behavior of a mutable data type, because I'm overriding the pointer, right? So I'm mutating the pointer like this, but I'm not mutating the actual type. And we can tell because out here, if I print my text, right here, I pass in my text, which gets represented as text in. and I do this change, but this doesn't change. This change doesn't propagate to the myText variable globally. So we should see the original string printed out, just to prove that it's not being mutated, right? So the variable's value is changing, but the actual object is not changing, right? So hello there still has the punctuation characters in it, right? So I'm just saying text in equals text in dot replace punct with empty string, and this is effectively deletes the punctuation character by replacing it with an empty string. And then I save it into the new value of text in. So once that's done, I have all the punctuation removed. Then I'm just going to have an accumulator pattern. We'll just start with a list, and we'll say for word in text in dot lower dot split, and I'm just lowering it because it said, what did it say? Return a list of unique quote cleaned words, and I thought, well, lowercase seems like it would clean the words, and it sort of helps with reducing duplicates, right? How spelled with a capital H and how spelled with a lowercase h are the same word, so in this case, it's not going to draw a distinction between those two. So we'll just iterate through the lowercase words, and we'll split that lowercase string so we get a list of all lowercase words. Text in also has no punctuation in it at this time because of this. Then I say, if the word is not a member of list plus remove words. So remember, I don't want duplicate words. I only want unique words to be represented here. So, and I also don't want words that are in the remove words list, right? So I could do this with like a nested condition, like if word not in list, and then immediately inside of that say if word not in remove words. But if you have an if statement contained within a condition, and there's no other code within that containing condition, you can turn it into one condition basically. So you can use an and. In this case, I'm concatenating whatever the current value of list is to make sure that I'm not adding it to the list if it's already in there. I'm concatenating this list with the remove words list to just check them both at the same time. I'm just saying, hey, just concatenate these two, and if the word is not a member of the combination of concatenating both of these together, then we'll append it to the list. So we only want to append it if it's not one of the words that we don't want to append, and if it's not in the list. So concatenating them just saves me from having to write 2 lines of code. And then I just return the list. Initially, for some reason, I thought we were supposed to join. So I joined it as a string, and I got a string in return. And this one will only remove periods here because I'm overriding punct list like this. So I still have exclamation points, question marks. It's kind of silly, probably want to remove all the punctuation, but cool. So that was my solution. Okay, cool. I will paste that. I'll work on that later. Come on. Oh my gosh. Computer's just not scrolling. Are we not scrolling now? Are we having a crash? Okay. That's not, well. We've got some weird delay. Okay, we're scrolling again. Oh no, we're just at the end. Huh. Okay, yeah, like I said. We're just at the end of that. That's good. We've got some more data types to discuss. We're about halfway, which is good. So let's take a break. Let's reconvene. It's 8 after the hour. Let's reconvene at, I'll be generous, we'll do 14 after the hour. All right, cool. We got a couple questions here. One is, instead of using punct list and remove words as parameters, is there a way to use these as variables? Yes, it was just my choice to do these as parameters, but I really am just being a little fancy lad when I do this, honestly, and I should probably just do this the simple way. So if I wanted to use these as just variables, I can just make them variables in the function like this. Right, so now I just have a function takes in text in, and we have our variables up here that I'm just declaring in here. The difference is now they are no longer available to be overwritten explicitly as parameters, which in this case is fine. Yeah, I just wanted to show a variation on that. Yeah, I think we'll leave it there. The star thing is, yeah, I shouldn't have opened that can of worms. DM me if you want to know more about that, and or at me in the channel, and I'll explain it. Respond to it after class tomorrow or something. Or we can talk about it after class. And then the other question is, what are some real world scenarios that we will encounter a lot that will require using the strings we've been practicing? So anything to do with text processing will eventually require split and join. There's going to be, yeah, there's a lot. I mean, strings are a very central type. I mean, in every programming language that I've used, you use strings a lot. They're I mean, arguably like the central type. Not quite, but yeah. So in terms of like I don't know, I don't have like a I don't have a specific scenario in mind, but it's more that like I'm spoiled for choice. Like no matter what line of work you find yourself in, if there's not a text processing element to it, if you're writing code in any language and there's not a text processing element to it, I'd be shocked. You know, so you're gonna be dealing with strings as types, one way or the other, and specifically what we've been, you know, covering today with split and join and remove and the other string features like are going to come in very handy. So it looks like my code is also broken, which is always fun. Oh, that's interesting. For punct and punct list. I don't know what that's about. I'm not going to worry about it. It was working a while ago. We need to move on. We got one more question, or yeah, just saying thanks. If you can post both versions of the solution on the slides, that would be fantastic. Yes, I will. I'll can you remind me that after class? Just say like, hey, do both versions of the clean string after class, and or DM me, and I'll make sure to include it. Cool. Okay, so that's more strings. So now on to other data types. So if you look through these slides, which, you know, hopefully you have the slides up in front of you, This is going to cover, this talks about sets, tuples, and dictionaries. I'm going to do this in reverse order because dictionaries take the most time and they're the most important. Tuples they're useful to know about. You're not going to use them as much as you'll use lists. They're very similar to lists, but they have no mutable methods. Think about it like we'll just cover tuples real quick and come back to this if we need to. I'm going to print the the directory of lists. Now, if I went through here and I looked at all of these are all the, the regular methods for lists without the dunders, right? And as I've said, just ignore the dunders for now. But if you look at all of these and you delete all the ones that change the value of the list, so append, clear, copy doesn't change the value of the list, but you wouldn't need to copy if you couldn't change the value of, like if it was immutable, copying wouldn't be meaningful anyway. So we don't need copy. Count doesn't change the value. Extend does. Index does not change the value. Insert, pop, remove, reverse, and sort all change the value. And so if you removed the mutable functionality from lists, you'd end up with tuples. And sure enough, if we print out the directory of tuples, can you guess what methods it's going to have? Count and index. Those are the only two methods for tuples. So, they have all of the immutable methods that that lists have. There are some like under the hood details in terms of how that data structure is stored in memory and dealt with by the internals of your computer. But if you want to like, how do I work with this sort of rule of thumb? It's a list without the immutable methods. So we'll get back to that in a second if we have time. But I want to spend most of our time with dictionaries. Sets are important to know that they exist. It's kind of a funny thing with sets. And this is anecdotal because I'm speaking from my own experience. I don't often use sets. It doesn't come up that often. There's been times where I've been dealing with information in a way that sets are very useful, and then I'm really glad they exist. And then I don't use them that often outside of that. So I could foresee, depending on the line of work you're in, whatever specific problem that you're working on, or I could see them being like, yeah, I use sets every day, or I could see them being like, yeah, I've literally never used a set in my professional or personal coding life other than to just say, hey, here's what a set is. So you might find them that you use them all the time. You might find that you don't use them that much. I think you'll probably find that you don't use them that much. And they are kind of an outlier in terms of the collection types. So we'll talk about that a little bit too, but we'll get to that last. So I want to focus mostly on dictionaries because I think dictionaries, now I wouldn't say dictionaries are complicated, but I would say they have more moving parts in a way. Okay, so let's sort of juxtapose this against a type that you're more familiar with. I'm hoping that you're more familiar with lists. So if I have a list, hey, hello, hi, yo. So I've got this list of words. These elements, these are the elements, the words, the strings, these are all the elements, regardless of whatever data type. They could be numbers, but we refer to those as the elements of the list, okay? So the elements are the values in the list. For however many elements I add, there is always implied, without me having to do anything special, an index associated with that element. So I don't have to say, well, hey, this high here has to be index 2. I don't have to tell it that that's index 2. I don't have to tell it that hey is index 1, or excuse me, index 0 after all this time, and I still think in one based. So I don't have to specifically say that or explicitly say that. It's implied by the position that it takes in the list. If I append something, it's going to append the element, and it's automatically going to know the index for that element, right? So dictionaries, you can think about a dictionary as having the elements of a list, but instead dictionaries don't have numbered indices. They don't have an index that's just there for you to use when you're ready to use it. They have keys that have to be explicitly set. So let's look at a dictionary. So a dictionary is comprised, the elements or the items in a dictionary are comprised of key value pairs, right? So let's do a dictionary. And let's just say, what should I call this? Greeting 1 is, hey. I'm trying to make the same thing in dictionary form, but struggling a little here. We'll do greeting 2 is hello. Greeting 3 is hi. You get the picture. So on the left, we have the keys. On the right, we have the values, right? So in the context of a list, if I wanted to retrieve this hello, I would supply its index. I would say print list sub 1. Same thing with the dictionary, except remember, I don't have a key. I don't have an index. I have a key, right? So in order to refer to this hello, I need to specify its key, which is greeting 2, and that has to be a string. So the key itself has to be an immutable data type. So strings are immutable, tuples are immutable, integers, booleans, floats, those are all immutable types. Those are all fair game for a key in a dictionary. I can't use a dictionary as a key in a dictionary. I could use a dictionary as a value in a dictionary, but not as a key. I can't use a list because a list changes size. Imagine what it would mean to have a key in a dictionary that could just change, right? That key could just not be the same key because you have a mutable type. So, it could just change right out from under you. So you wouldn't want that key to change. You might want to delete it. You might want to change the value. But if the key itself just changed, then you don't have a reliable way of retrieving that value again, which kind of is the point of a dictionary. So so these will give us the same thing, right? So you can think about this looks, the thing I think one of the things that trips people up is that, like, visually these are not the same thing. Maybe I'll try to rectify that a little bit here. Right, I'll try to get them to look similar. But visually these look really different, right? These look like categorically different things, and they are, but there's something very similar happening here. I have a mutable collection that holds values, that holds elements that I want to retrieve. And this is a similar mechanism for retrieving elements, right? Here I have a numbered index. That numbered index is implied by the position of the element. I don't have to explicitly say anything, just, I can just put the elements in the list and retrieve the elements by the associated index that was implied, right? Whereas I have to make sure that I supply something for the key when I'm adding keys to a dictionary. That key is not going to be generated for me. I have to actually make it be in there. So that's, in a nutshell, that's what a dictionary is. So dictionaries contain key value pairs in mutable, unordered collections. So this is actually kind of funny. If you print out a dictionary, it's going to print out in the same order every time. This is actually a new feature as of like October or November. This was added, but it used to be that if you printed out a dictionary, the key value pairs would always stay associated with each other. Obviously, they'd need to, but the order in which those pairs would occur and be printed out would be arbitrary and unpredictable. So it was usually the case that you'd put them in greeting 1, 2, and 3, and then you'd get them out 2, 1, 3, or 3, 2, 1, or whatever. You'd get those pairs printed out in just some random order. Same thing with iterating through a dictionary. You used to iterate through the key value pairs in a dictionary, and it would iterate through them in a random order. And there are reasons why that's not helpful. You can imagine that there are certain times when iterating, the order in which things were added in needs to be observed when you're going and iterating through a dictionary, right? So I think that's why they changed it ultimately. However, if we have, let's do this. Let's call this DC1, and then we'll have another one, DC2, right? Okay, so if I print these out, so they have the same contents. They have exactly the same contents. These have exactly the same contents in a different order, right? If this were a list, these would not be the same value. Now, these are different objects because I'm declaring them as such. So these are two lists that hold the same data in a different order. And I want to see if their values are considered the same. So if I print DC1 equals DC2, true, right? So by contrast, LS1 equals, we'll do this, equals this. Oops. And then let's do LS2, and I will change the order of these two. So if I see it, so even though these lists have the same elements, they're in a different order. Those values are not the same. LS2. So list order matters in terms of list value, right? The order of the elements in a list changes the value of the list. These are neither the same list in their ID, nor are they the same list in their value. These dictionaries contain the same values, they contain the same key value pairs, therefore they are equal in value. It doesn't matter the order that they come in, that they are presented or displayed or iterated through, even though that order will be consistent, the order will follow the order in which the key value pairs were added. But it's, even though you might not see dictionaries as like coming out in different orders, it's important to think about them as not having an order. The order that they have is an illusion. It's there for convenience, and just, I think, sort of cleanliness, and it's not there for the same reason that list order is there. Okay, cool. Probably goes without saying, but to declare a dictionary, we use these curly brackets. Often we'll declare a dictionary with empty curly brackets, an empty dictionary with just empty curly brackets like that. You can use, and sometimes you'll see the dict constructor function like this. But yeah, sometimes you can actually do this. This is kind of a weird one, but you can do like key value with a list of tuples like this. This is super weird. There are old languages that don't have formal dictionaries that use lists of or arrays of tuples, and just call them dictionaries, and that's sort of a legacy, weird legacy thing. I think Pascal is like that, something like, or maybe Algol. Weird old languages. Okay, cool. So that's basic dictionaries. So I touched on this earlier, CRUD. We have a collection type. We want to know how to create, read, update, and delete elements in a dictionary. We also want to know how to create the dictionary itself, read the whole dictionary itself. Updating the dictionary is really just updating or adding or something, so it doesn't apply to the whole thing, and delete the whole dictionary. So let's look at each of these. So C, to create a new dictionary, it'll be D equals empty dictionary. That's pretty easy. I can supply key value pairs by just typing them in. The key is separated from the value with a comma, or excuse me, with a colon. And then each key value pair is separated by a comma. So notice key, colon, value, comma, key, colon, value, etc. Cool. Oh, you remember Pascal? No, that's cool. I like those old languages. I think we should use them. Not seriously, but just because they're cool. Okay. Read. So reading a dictionary, well, that's pretty easy. We can just print the dictionary. We're talking about the whole dictionary, right? Update, like I said, doesn't really apply to the entire dictionary. And delete. This applies to any type. I think I've covered, at least touched on the del keyword. If you want to make something go away, del D, and then let's print D. We'll get a name error. So we made that name and the dictionary itself that the name was referring to just go away. So up until that point, it worked fine. Print the D, get an empty dictionary. Cool. Okay. So that's pretty simple. Let's look at how do we create key value pairs. So let's assume that we have an empty dictionary. So how do I add in a key value pair? Well, like I said, I could do it here, like key, and then value would just a number, key 2, val 2, I don't know. Yeah. Something to mention here, you can't have two keys of the same name, and we'll look at that when we look at update. So how do I create a new entry into this dictionary? And we'll just, like I said, we'll do an empty dictionary. So I can say D sub, and then what do I want my key name to be? You should actually like have a theme with this. Like maybe I can make it like a car. Like a car has a make. So D sub make, and let's call this car. Let's call it car D, car dictionary. So the make of this car is going to be a Toyota. You know, it get me excited for vintage languages that aren't used anymore outside of banking and nuclear reactor infrastructure that's too legacy to update. But I'm resisting the urge. Okay. All right. Okay, so back to dictionaries, sorry. So car D, so if I want to have this car to have a make, I'll say car sub make equals Toyota. So I use the same like nomenclature for dictionaries as I do with lists, where you have like list sub I or whatever, list sub 0 equals whatever the element is. But I'll say lists or D sub make, so car D sub make equals Toyota. So if I print this out, print D, of course. Oh wait, I'm wondering why my code is running slow. I might have just remembered something that might make this speed up. I think I have another file. Oh my gosh, I have another file watcher operating. Okay. Hopefully that'll speed up the execution here. I don't know why it's being very laggy. Let me restart this. Well, it's still slow. Whatever. Okay, so my car dictionary now has Toyota. So let's add another one. I'm just gonna do so what's a model? A Toyota Civic. I know what I'm doing. 1983 Toyota Huntsman, fine. Toyota Huntsman. And year, you get your wish. 1983, okay. Oh, that's the picture. Oh my gosh. Okay, that's cool. So this is our 1983 Toyota Huntsman. And if we look, it's being printed off in the order here that we added them in. So if I add them in a different order, it makes you think dictionaries obey an order like lists do, but it's not quite. So this is year 1983, make Toyota model Huntsman. Cool. Okay, so this is how we can create records in a dictionary, create and add a single record in the dictionary. Read, well, read is just pretty easy. I can read the whole dictionary by printing it out, or I can read a specific field by just saying, what's the car sub make? What if you want to add another model name to the key? Like we realize that it's not a Toyota, it's a Porsche. That'll be an update. We'll talk about that in a second. So if I want to know the make of this car, it's I can say car sub make, and it'll give me the make, which is Toyota. Quick quiz. Who remembers the type function? Hopefully all of you. It's a very useful function. Okay, if I run this, what is the type of car sub make? Actually, what is the type of car sub year? Yeah, year. There we go. So what is the type of car sub year? Collection. Apologies. So I've talked a lot about collection types. That's a I should have prefaced that by saying like that is a term that I use. I'm always understood when I use that, but that is not really official Python nomenclature. When I say collection types, I'm talking about types that are collections of things. So it's sort of a category of Python types. Lists, dictionaries, tuples, strings are all like a group of elements. So rather than like numbers, which just have a state. You could say those groups are also a state, but yeah. So apologies about that. So this is a good one. So the value of car d sub year is 1983. So what is the type of car d sub year? Does Python automatically identify the type as an integer? Indeed it does. So this is, I wanna bake this concept in early. This looks like some like heavy syntax or something. It looks funky, but you can think about this as basically a variable name. It behaves a lot like a variable name. Imagine I had, just imagine I had 3 variables and I just took out the funky dictionary looking syntax and I just made them variable names. Like you might even ask like, well, why would, like if you can do this, why would you ever use a dictionary if it just like makes it more complicated? The reason is that these aren't associated with each other. They have nothing to do with each other. They're just 3 unconnected variables floating around. Yeah, and these variables also apply to 1983 Toyota Huntsman, whereas I could use a dictionary with year, make, and model to describe any car, right? So, they're all nice and bundled up into a single dictionary that I can pass around that represents my car or whatever. If I drove 1983 Toyota Huntsman, which I don't know why I don't. Obviously I should, but this, what's happening here is pretty similar to what's happening here. If I said, what's the type of car d year variable, you're like, oh, that's an integer, right? So you can read this very much as a variable that just is sort of collected inside of a dictionary, associated with that dictionary, even though it looks different. So like a variable, somebody just asked this, what if you want to add another model name to the key? So I think you're saying, what if I wanted to say car d submodel equals Civic, Toyota Civic? Oh shoot. I have to actually print out the dictionary so we can see what it is. So what's going to happen here? I mean, imagine if cont'd model was a variable, you would say, well, it used to have a value of huntsman, now it has a value of civic, and that's the same thing here, right? So notice I can't add another key with the same I can't add the same key twice. I can't have two of the same key, because how would I access one or the other? If I had two keys that I could print out as car sub model, which one do I mean? Huntsman or civic? So in this case, in the case of dictionaries, you can override or change the value at a given key, just like you could of a variable, right? Like same thing here, right? If it was a variable, this would make perfect sense probably, right? So what's the value of cont'd model? It's going to be civic, not huntsman, because it overrode the last value. What if I want huntsman and civic? Like if I want them both to exist like simultaneously under a key called model, I think the closest approximation would be to say I mean, we could concatenate. We could say plus equals civic, and then we have a 1983 Toyota Huntsman Civic. If this ever wants to run, yeah. So now it's Huntsman. This is one string. Another thing I could do, I guess, if I wanted both models, we'll overwrite it with an empty list, and then we'll aha. So now let's look at this. I know I'm laughing, but I like this question. This is great. Okay, so we have a 1983 Toyota with the model is going to be a list of models because we want two models. So how do I add those models in? I'll make this a breakout. So go ahead, give me let's say 2 lines of code to add in Huntsman and then Civic into that list. And this is a little bit of an unfair breakout because I totally didn't show this is in the dark. But you technically have enough information to deduce the right code, and I don't really expect you all to necessarily do this. If somebody does, then that's cool. But if not, that's fine too. I just want you to think about it. I want this to be a brain teaser. I want you to be thinking, like I've got a list as a value in a dictionary. If this were a, I'm on the verge of just solving it for you. But you know how to manipulate lists. I think it's safe to say that at this point, most of y'all are having, have had some familiarity with manipulating lists. So. To think about what you know about manipulating lists, and think about what cont'd submodel is. Cont'd submodel is that list. Okay, I'm going to show a solution. So if this were called, aha, you got it. if this were called cont'd model a variable, you'd know probably that you could append to it. Right, and you can do that. You can do that with the dictionary, even though it doesn't seem like you could, right? So we could say dot append civic. That code would work as well. Yep. Yep, by different means, but yeah, that'll do the same thing, right? Okay, so now let's look at deleting an element. So this is, various playing around with updating elements. So I want to be clear here. You might look at this and go, oh, well, I didn't know append worked for dictionaries. To be clear, you're not appending to a dictionary. You're appending to a list. The list happens to be a value in a dictionary. We access that value by saying, specifying the dictionary and then specifying the key where that value resides. So that value resides, that list resides at cont'd submodel. cont'd submodel is in a dictionary, but it is a list. Del D sub, because the Toyota Huntsman Civic is a timeless classic, we need no year. I mean, we all know the Toyota Huntsman Civic. String is no attribute append. Oh, there we go. Cool. So make is Toyota, model is Huntsman Civic. All right. Cool. So that puts us about at time. We've talked about tuples enough that I think we're good on those. And I'm just going to assign sets as part of homework. I can run through sets really quick. So to make the use case for sets is when you have a collection of things, you don't want duplicates, and you don't need to retrieve the elements from the set. Sets are not useful for archiving information to be retrieved later. Lists and dictionaries and tuples are, but not sets. So they're a little bit weird. You generally will you'll store your information in whatever list or what dictionary, and you'll parse that into a set or cast it as a set only when you need it. You can use curly brackets to initialize an empty set, although Python will sometimes get confused about this being a dictionary. So I would say don't do that. If you want to create a set, use the set constructor method and pass it a list. If I have 4, 4, 6, 3, 5, 1, 5, print my set. Just print this off real quick. So I have 2 4s and I have 2 5s in here. Notice that the set version of this, 1, 3, 4, 5, 6. Are sets sorted now? Maybe sets obey an order now too. That'll be interesting. They appear to be sorted. Interesting. Okay, it's not important. So the set of this information is 1, 3, 5, 4, 5, 6, because the sets by design cannot contain duplicate information. The same is true for dictionary keys. So you can think about it like it's a data type that is like the keys of the dictionaries without the values. So they're like keys without the values. So you can't have duplicates of them. Excuse me. Ooh, apologies. Yeah, so sets are useful for this. They're useful for removing duplicates if that's what you want to do. And also, let's see. The big use case for sets is doing set operations. So let's say I have my set 1 and we'll do my set 2. Right, so the set operations are going to be, I can say my set 1 minus my set 2. This will tell me all the elements in set 1 that are not in set 2. Vice versa, this will tell me all the elements in set 2 that are not in set 1. An alternative to this is to use the dot difference method. These are exactly the same. You can use the subtraction operator because that is a difference, and you can use the difference. Oops. You can use the difference method, and they do the same thing. So these are the kinds of things you can do with a set, and that's what makes them useful. And there are 2 more as well. I'm just going to do. Oops. So we can do that. We can also do the union. And the intersection. So the union is essentially the superset of both of those sets, or the combination of both of those sets. So it's all the elements in both of the sets. The union is just both of the sets added together. The intersection is all the elements that are only, all the elements that are in both sets. So all the elements that they have in common. And these are the important set operations: difference, union, and intersection. If you want to do one of these 2 things, or one of these 3 things, sets are extremely useful when you're analyzing difference or commonality or combination of groups of information. Sets are, they make this so much easier than having to do this manually with a list or a dictionary. So this will save you a lot of work if you want to do the difference, union, or the intersection. If you're not trying to do one of these, sets really aren't going to be that useful for you. So they're good to know about. They'll probably come up for you eventually, but probably also won't be a day-to-day data type. Cool. I'm going to leave that right there. I know we went a little bit over time, but we managed to finish all the material today, and I'm just going to call it good on tuples because we've talked about those before. So that'll be it. If you want to stick around for questions, feel free.